Recently there's been a little bit of talk about sudden battery failure on electric vehicles. Well, batteries don't suddenly fail, they gradually wear out over a very long period of time, and most electric vehicle batteries last for at least 10 years. And when I say last 10 years, at 10 years they've still got 60% of their original capacity, so they're still usable, although they could probably do with upgrading. And you can upgrade them. If a battery pack is said to have suddenly stopped working, then it's going to be a very simple component. This is a battery pack of a Toyota Prius, a Gen 2 one, and it's a fairly simple thing. It contains a number of cells in a row, and at the end there's some electronically operated switches called contactors, a bit like relays. And they switch this pack on and off, only when it's done a load of safety checks. So there's quite a lot of technology involved with that, and those contactors can wear out. It's not very common, but they can do it. It's usually the positive contactor that goes first. There's a contactor on the positive wire coming out and on the negative wire. And there's also a thing called a pre-charge contactor, which helps get the thing up to power when you first switch it on. Now, if the contactors fail, the electric vehicle won't work anymore. And if it's a hybrid, then you probably won't be able to start the engine. So it's quite an important device. Now, a full battery pack on a battery electric vehicle might cost £16,000. And if you have a contactor fail, and this happens in things like old Nissan Leafs and the such, like the positive contactor will weld itself shut, you can get those contactors for about 40 quid. You have to drop the battery pack out, open it up, unbolt the contactor, bolt a new one in. Makes it sound fairly simple, but there is a huge amount of danger in here if you don't know what you're doing. If you do know what you're doing, it's reasonably straightforward, but we don't take any risks. So at the moment, this battery pack's isolated. There's an isolator that goes in the inlet, that's off, so I can take this cover off. And I can show you in here, we've got the positive contactor, the negative contactor, and the pre-charge relay. So swapping one of those out is not a massive job. Now, when the battery gets very old, then it's time to start swapping the cells out, and then we need to get into the inside of it. Now, before we open up the bit with the cells in, which is where there's some very high voltages, we need to wear the right safety kit. That's really, really important. So I'm just going to go and get my gloves on. Now, the gloves we use are rated for high voltage work. These are rated for 1000 volts. But we have to test them before we use them each time. So what we do is a little inflation test and check that there's no punctures, because if it's punctured, it won't save your life. That's all good. And then what we do is we put glove liners on, because otherwise the rubber gloves get really nasty on the inside. So we always wear our snooker referee gloves, then our rubber gloves that we've just checked. Now, if I open this case, what we've got here is a whole row of cells. Actually, each one of these grey blocks contains several cells in a row, and they're all joined together with what's known as bus bars. So if I pull this bit off, you can see these metal links that join them together. So we've got positive, negative, all the way down there, and another set of bars up the other end joining them together. So overall this produces 200 volts, and that is enough to kill you and hurt you all the time it's doing it. So don't take any risks. Now, what you usually find is that if the battery pack's worn out after 10 years or so, one particular cell or group of cells will be more worn down than the rest. So you might have 90% of those fine and a couple of them are a bit dodgy. You can undo them. There's a big bolt that goes all the way through there and another two underneath. Unbolt them, take them all apart, swap those units out, and then you get your battery pack back to almost full capacity, certainly very usable, without a hideous amount of expense. So we check the voltage of each one of the blocks, and if I just get that out, and then we can see which one's at fault. So it's not exactly rocket science, but you do have to do it the right way. You do have to have the right equipment. So between there and there we've got 11.6 volts, 11.9, between there and there 14.4. So there's a big difference. So something between there and there is less voltage than between there and there. And then we can home in on it. What I'd next do is take those little plates off and measure from that end to that end of each one of these cells and find out which one's no good. Then I can replace that, and you can pick these, they call them blades in prices. You can pick those up for a very small amount of money. People are stripping cars apart, taking the batteries apart, testing them and selling the good cells on. What happens to the bad cells? Well, they still have a use. If it's still got 50% capacity, it's not going to be great for use in a car, but it's still great for a power wall on the side of a house. You've got solar power, charging up your power wall, and if you just need more capacity, you just put more cells in there. So second life cells have got a really good use, and that will carry on for another 10, 20 years. When eventually they become problematic in that setting, and then you're talking down sort of 20, 30% state of health, then they can be fully recycled. There's a lot of myths about recycling these cells. You can recycle them completely. There are some plants around the world that will completely recycle them. Often they don't recycle all of the metals out of the batteries because there isn't enough demand for them. That's the only reason they don't do it. The price of lithium, for instance, is so low it's not worth them recovering it from old batteries at the moment. The second problem is there's just not enough old batteries coming into the market to make it worthwhile building new factories to recycle them. I'm sure that will change in the near future. So all in all of these cells have got certainly a 10, possibly 15-year life in vehicles. Some of them might have to get swapped out after 10 years. The rest might carry on for maybe 20 years. And even after that you can use them in power walls. And the more power walls we have on houses, the better the grid balancing gets. More solar power, you've got energy independence. You know, imagine if you had enough solar power and a battery pack on the side of your house, so if there's a power cut, your house just keeps going as normal. Everything still works. That'd be pretty good to be that independent, wouldn't it? So there's a lot to be said for power walls using second life cells out of cars. So if you do have a problem with your hybrid or battery electric vehicle, there's a problem with the battery, call an expert. Find out how to fix it. One of the problems we're finding at the moment is that a lot of main dealers aren't trained on how to take these apart. They just view the whole thing as one component, and if it fails, they'll replace the whole lot. And that's where we're seeing these stories of £16,000 bills to change a battery. It's not necessary. There's a wider question as to who warrants the repairs and all the rest of it, so it's not a simple business case. And if you're thinking about doing repairs like this yourself, then only do it if you've been fully trained by professionals. It's not difficult, but there are some real pitfalls if you don't know what you're doing that will kill you and hurt you all the time it's doing it. So get trained first. So I think there's a lot of really good future for vehicle batteries, both in vehicles and in power walls and all sorts of other things. And knowledge is power, really.